good afternoon. For those of you that are new, welcome to North American Dark Skies, Michigan Aurora Hunters, and Wisconsin Aurora Hunters. Um, the theme of today is keep calm. We haven't had everything go exactly as planned, and there are reasons for it. Common sense says let's learn about the science so you know what's happening. So when you get out there and they say things are supposed to be there and they aren't, that you know what's happening. So we're going to walk through everything that has been happening and is happening, and I'm going to explain it in simple terms. This is going to be a long video, but for those that are just learning, it's going to be an excellent video. For those of you that want the news, it's a good one to listen to because I'm going to get into everything that's happening. So let's get to it. Going to our solar flaring. Now I'm going to start by explaining the difference between a flare and a CME. A flare is light and radiation. It moves at the speed of light and can reach Earth in as little as 8 minutes. It does not necessarily give us auroras every time. If it is quick and goes up and down in a very rapid motion, then you don't necessarily think it's going to do anything. But all of these mostly have a very long duration that lasts several minutes to several hours. These more than likely have all produced CMEs. And a CME is, let's get to a brief explanation of what a CME is so that people understand it. In our sunspots, we have these filaments, these lines that reach up. They're magnetic lines. They all go in one direction. They come up in one direction and go down and return to the sun in a circle. Okay? It's like the wiring in your house. It has to make a circle. And I'll explain how that erupts in a minute when we get more into it. So this is a diagram of a filament reaching out from the sun. You can see here it's going in one direction. And you see these little spirally lines? This is the CME plasma, the electrons and the electrically charged or magnetically charged plasma, mostly made of helium molecules. Okay, that's an important part of this, and I'll explain that to you toward the end, but it's mostly helium plasma. So think of the slime we used to play with as kids. You know, your mom would give you a birthday gift and it was that funny slimy goop that just kind of stuck together, and you could drip it and mold it and shape it, and it was just kind of fun to play with. Plasma is a slime. Okay, that's kind of what you want to imagine it like. It's just like the slime. Okay, when the sides of that diagram, okay, when the sides of this get close enough together and they bump into each other, they create a light flare. So if this side over here bumped this side over here, that electricity would cause a bright flash of light. But if it twists together, it can break this line, and all of that plasma and all of the things spiraling around it can fly off into space, creating a coronal mass ejection of plasma. And then it will snap, the ends of it that are still connected to the sun will snap back together magnetically, and it will cause what's called a magnetic reconnection flare. So a secondary flare. So that's why when you're looking at the graphs of the sun, these really large flares in CMEs will have 1, 2, 3, 4 flashes to them, because that's the magnetic reconnection coming back together and creating an additional flare. Okay? I hope everybody's following me and it makes sense. Okay, so we have had a lot of M-class flaring. We've had M-class flare here, M-class flare here. Here is an X-class. We've had an X-class 1.3. Not particularly a long flare. Over here in the middle, going into September 13th, the morning of September 13th, we've had a long duration of C's and M's that tied together. So this one, maybe from more than one spot, but it all tied together. And then early this morning, we had an X4.5. This is the flare that everybody's excited about, but before you get excited, calm down. Keep calm. Learn the science here, because it's not going to be as exciting as you think, and thank God it isn't. All right, so we're going to go up to sunspots. So the next part of this is you have to understand where your sunspots are. And we're going to kind of divide this into three lines. So your first line goes right down the middle. This is your Earth-facing center line. Okay? Once things hit that center line, we know it's going to be a direct hit. Then we're going to draw a line over here, like way over here. And we know that once that gets to that point that it's past that line, it's probably not going to hit us unless it's a really, really big flare that's moving, that's horizontal in shape, so that it's more oval and long and wide than it is tall. If it's tall, it won't hit us, but if it's wide, it will. And when things are on this outgoing limb, it kind of spirals backwards. And a neat experiment you can do with your kids is take a balloon, cover it in a really sloppy, slimy paste, and tie a string on it and spin it, and watch how the paste flies off the balloon. You'll see that it spirals backwards from the way it's spinning. And that's how the plasma flies off the sun. It flies backwards. Okay? So, once you get to the center line, it's going to hit you. Too far past this line over here, it's going to miss you unless it's really, really wide and really big. Over here we have a line, probably just about where this sunspot is, that it probably won't hit you unless it is super wide and super big. And then it can graze you. And this morning's X-class flare came from 3825, and it was very large, and it was very wide, and it will graze us, but it is, thank God, it's not going to be a direct hit. And I'm saying that because a direct hit from something that large can short out internet, electrical services, anything that has power to it, GPS, satellites, phone service. It can all be discombobulated by a large solar storm. So we want good, but not too big. So, last night, before the X-class flare, we had 4 sunspots that were called beta, gamma, delta. Let's look at the classes. So we have an alpha class, which is 1 spot, and it's just 1 spot. Beta is a sunspot group that has positive and a negative. And there's a simple division between the polarities so that it's not really tightly wrapped, just yet. It could produce a sunspot, but it could not too. When we get to when we add gamma in there, it means the spot is become complex. It has positive and negative polarities, and it is irregularly distributed, but can't be classified as bipolar. It means it's not a mirror image of each other. It's very irregular in shape. It's very irregular in where things are connecting. Beta gamma, the bipolar sunspot group, is complex enough so that no line can be drawn between the opposite polarity. That means the red and the blue are so tight together that there is no space between them. They are like right tight together in the deep colors. When you add delta, the umbra of the opposite polarity is in a single penumbra. A beta delta group is a group that is generally beta magnetic configuration. It contains one or more delta spots. Beta gamma delta, and this is the big one. The sunspot group is beta gamma magnetic configuration but contains one or more delta spots. This is the monster you're looking for. It has positive and negative polarities, and it has umbra in a single penumbra. I know that's kind of complex in but that's what those things mean. Now, how to look at these sunspots? Looking at 3414, which is on the upper side, outgoing limb, this one is losing the number of sunspots, but it's gaining larger sunspots. So this one is reorganizing. As it going around the limb, the farther around the limbs, they've been developing into bigger spots lately. So this is something that it's reorganizing itself. It's not dying, it's reorganizing. 15, it's getting larger spots. This one, again, may survive the circle around the sun. It may be reorganizing. 316, it isn't changing at all. It's down to one spot. It's not a very large size. This one could be a dying sunspot. 3222, it's going down in number of sunspots. It's going down in size. I would say more than likely this one is a dying sunspot. Sorry about all the noise. My phone is just bingling like crazy. Again, 23, it may be dying in size. It's not doing anything, but it could just get on the back side of the sun and then decide to reorganize. 3824 is facing us. It is growing in size. It is growing in number of sunspots. This is in the middle of reorganizing itself. And I would say give it a day or so, and it actually probably will produce more activity. Now, let's look at our big sunspot. This one is where I told you your beta, gamma, delta is the one you really want to look at. This is irregular in shape. We have penumbras in umbras. So we have, this one is, there's a spot, there's a spot. We have big spots within a grouping that is very irregular in shape. And if you look at, there is no defining space between them. They're very tightly wrapped. This is very likely to continue to produce. I would say it's probably going to die off for about a day and a half till it gets center stage. Once it clicks past center stage, it probably will reorganize and go back to town and deliver more. The sun takes almost like it's breathing. And I all the time you'll hear me say it's taking a breath. It's like we are. It expels energy, and then it's got to sit back and it's got to take a breath, reorganize itself before it produces more energy. And it's a pattern that happens. And if you watch it consistently, this is a pattern that happens. Our last one is a new spot that is just developing. It is a beta spot. It's a baby spot, but this one is more of a mirror image of each other. So this one would be a more regularly shaped sunspot, or not considered irregular in shape. But again, you can begin to see that we have a mixing of all these positives and negatives in between each other. That's important, because the closer that positive and negative gets, the more chance you have of a CME happening. Now, let's go back. We have had several large CMEs. We started at 33 on the night of or early morning on the 13th. That means everything is still coming at us. And it is ended at 57. That means we've had what? 24 spots, or CMEs. So let's look at the big ones. How we read this graph. So we go here to the time and date it happened. It happened early in the morning. This one lasted for 10 hours. So the amount of the flaring and the CME lasted 10 hours. It was a long duration. These are the angles that it's hitting at. Over here we have the lowest speed it could be moving is about 200 kilometers per second. The fastest moving is about 1,562 kilometers per second. It is considered a half halo hit, or 180 degrees. That means half of it's going to hit us. If it's 180 degrees, more than likely it will hit us. Let's look and see where it came from. This came from over here. So more than likely it's from it could be from 15 or 23, but it also could be from the ones right here. If it's because it's saying 180 degrees, I'm guessing it's hitting in the middle. So it's coming from these central sunspots. It's whooshing out this way. That means it's going to circle back to us. This is going to be a direct hit. So we have something coming that's going to hit us. It's fairly dense. Okay? This is what we call a cactus view. It gives us more detail. Velocity, the peak velocity is hitting there. An angle from the north is over here. So not some of it's going to hit the center, it's right at us, but it's probably more than likely going to swoop back at us. And there's an image of it in motion. So that's how you read that. But here's the interesting thing. If you back this up, you have this explosion, but at the same time you have an explosion over here, which, if you're looking at what's leaving the sun right here, this actually is a full halo. They're only counting this explosion in an isolated event, because they only count one at a time. but those happen in quick succession, and the plasma is still streaming out all at the same time in that 10-hour period. So you're actually going to have a full halo in there. Then we have, okay, we've got 1500, 1200, so this is a little bit slower. But then right behind it, we have this one that's taking off from the same region, probably the center region. It takes off, it's a little bit faster than the one before. Here's where we get into what we call a scoop shovel event. Want you to think of snow laying on your driveway. And you're starting to push a snow shovel across the driveway. So as your snow shovel pushes across that driveway, all the snow builds up on the front of it. Well, when a faster CME catches up with a slower CME, the same thing kind of happens. The edge of that faster CME kind of catches all that slow snow, or the slow plasma from the slower CME, and it builds like the snow on a shovel. And it'll cause the event to be bigger and spike bigger than what's expected. When you look at the numbers and you see, oh, I have 3 or 4 slow movers and then I have a really fast CME coming, that's when you go, okay, I know predictions are 50% wrong. 50% of the time they're either going to be bigger or lesser than they expected. But when I see 3 or 4 slow ones, or some slow ones and then a fast one, I want to err on the side of big. Okay? But if I see a fast one with 3 or 4 slow ones behind it, then I want to err on the side of small. Okay? So we got that one. This one is moving at 116 kilometers per second. It's not much. It's all coming from that same region, so we're probably still going to get a lot of stuff from that. This one is coming out probably from, what is it? Let's go up here. That one probably might have erupted from 22 and 14, because they would have been over here a little farther. So those probably came from 22 and 14. May hit us. Maybe. Not guaranteed to hit us. And then you walk through these other ones. That's coming straight out. That one's going to probably be a miss unless we get a graze. Now, this one, if you look, it's coming down and away, but look at here. You've got all this plasma that's coming straight at you. You've had several CMEs. It's all moving around the disc. It's all still coming at you. Now we're getting heavy on this side. There's a chance it could swirl back, but this is a point I would say we're going to lose density. We're going to lose the auroras right here in the prediction. Quiet's way down. Not much here. We could get a little bit from what's coming right here. It's lost its density. It's lost its strength. It's not moving fast. But look at here. We've got 1, 2, 3, 4, 5 really slow moving CMEs. Oh, it's not going to give me that one. Okay, we still have enough here that is showing movement all the way around the disc, with the most of it coming here, which might give us a small graze. There's still enough there that it's laying down plasma between us and the sun. Okay, here's the important part, because right here we have a fast mover. It's going up and away. It's not going to do much for us, so all this stuff is going to continue to build. Then we got another fast one moving right here. Which way did it go? It's moving off and away. That one won't hit us. they must be reorganizing some of the feed. So then we have a couple fast ones in here. This one definitely going to hit us. We have plasma down here in a half halo or 180 degrees. That's really strong. This is definitely going to be a hit. It's going to pick up all that slow stuff that's lingering out there. It's going to put it on a snow shovel. It's going to push it towards us. So here's where it's going to be a spike. Whatever time that spike hits, that's going to hit bigger than expected. And then we have another slow one, or a moderately fast one and a slow one behind it. But then we have this one, and this is your X-class flare that hit this morning. This is not what I would call a direct hit. It is going to graze us. Yes, we are getting a direct hit from it, but the strength of it will miss us. So the bulk of it, you can see the super dense. This is the white stuff. This is really, really, really dense. When it whites everything out, this is really super hot, really super electrified plasma. Thank God that's moving away from us. This would make a mess of our planet. Thank God it's moving away from us. Thank God that what's going to hit us is just the less dangerous plasma. Okay? This is the time you say thank you, God, for the near miss. You gave us something good, but you didn't hit us with the really powerful stuff. So we're going to get a direct hit. It's going to pick up whatever's in front of us and amplify it. So we still could have electric grid outages, still could see internet problems, still could see cell phone problems. So if you get out somewhere and you're having cell phone issues, that's why. Make sure you tell people where you're going, if you're going to somewhere isolated, to know to check if you don't show back up. And where to look for you if you go missing. So just plan that these things may happen with this one because, it's got some slow movers in front of it, so it's going to amp up a little bit. And then we have 3 or 4 behind it that are moderately big storms. One going this way, another blast, another flare. One going this way. By this time you could see it starting to calm down, but we still have a lot of plasma moving this way. And then we have another blast coming out the side here and one coming directly down. So we've got lots of stuff coming at us. This is not done. I look for this to continue for another week. And by the time the week is up, what's behind the sun is going to come find us. And let's go look at that real quick. So this is your 25 over here, just coming around the limb in this area, and your sunspots that are direct center disk are right here. This stuff is just around the limb, and this stuff over here has been dropping major flaring while it's been on the backside of the sun. So when this rolls around, it's going to start all over again, and we could get something big. So it's not done, and it's going to keep going. And I suspect we may keep going right through October. So let's look at, we are predicted to have really good activity through tonight. Lesser activity on September and the 16th. I kind of think we might pick up, depending on what happens in the next few hours, on the 17th. Because we have that big flare that they have not classified yet. That is slightly more earth facing. And this is a view of what's coming at the sun. so you can see the actual plasma as it moves in the last 24 hours. So, they have not updated our spiral predictions for newbies. How do I know when to walk out the door? Well, a little trick I've learned from observation is to watch this little blue line in the ACE mag. When you see this ACE mag go up and down with a lot of brokenness in between, it usually means that the ACE satellite that's sitting an hour or so out in front of us has taken a magnetic load. It's been hit by some sort of solar storm coming in, and you've got about 30 minutes to 45 minutes to get where you're going when that flip starts happening before it sets into a pattern. Also, you can watch your magnometers, your GOES flux, and watch when these, and your GOES magnometers, and when they start to go down severely, it means that they're taking a magnetic load, or when they start peaking up. And watch those. Now, we are predicted the 14th to about, if they're using, I'm not sure if they're using UTC time. If they're using UTC time for Michigan, that will be about 11. Wisconsin, it will be about 10. And it will carry on through the night. And then we are expected to have another good peak out in just before dawn on the 16th. We have more coming predicted. These are usually based on coronal holes, the 26th and the 27th, and then dissipating into the 28th. This is usually based on coronal holes. This is not based on, oh, we're going to have a CME. So CMEs are not predictable. We don't know that they're going to happen, so we can't predict them. They don't update it until one has happened. They've updated on the 10th and 12th to show that one happened and that we got a big storm. But they couldn't do that till it happened. So we won't know what the backside of the sun is going to give us till it gets here. Just know that you need to be aware that it's coming and that it's highly probable in that time that you're going to get something big. Now, let's talk about this weekend. Why didn't this weekend work? One reason it didn't work is because, at least in Michigan, I know we had a percentage of humidity that was above 70% and up to 90%. Humidity bends light like a prism. So it's like putting a sheet of wax paper between you and the auroras. If that humidity is really high, it's really thick wax paper and you can't see it. We also have some high cloud cover, and today we have cloud cover coming into Minnesota and Wisconsin. Michigan, you're still pretty clear. You've got high cloud cover, but nothing severe. And our humidity right now in Michigan is down under 70% and will be dropping for the next 3 or 4 days. So you have a better chance of seeing auroras in the next 3 days. The other thing we have going on right now is we have a series of wildfires that are very severe up in Canada, and you can see here, and we have this whole green area is smoke plumes. Anywhere you see the light green, that's a very heavy smoke plume. So we are under a lighter smoke plume now than we were a couple days ago. The last couple days we've had a very heavy smoke plume, and the winds have changed. That hurricane is blocked some of the stuff instead of drawing it up to us, has blocked some of it off, and we aren't getting the stuff from the Canadian fires like we were. All these little fires are just little forest fires or house fires. They're still fires. They document everything that's of any significant size. But this is what we're working with right now. And there won't be anybody but maybe Chicago and northern Illinois, southern Indiana, Tennessee, Kentucky, Alabama, Mississippi, Georgia, Carolinas, that may have a completely clear view if you don't have clouds. Wyoming and the western states have a better chance if you don't have heavy smoke over there. This is just showing us where we have the heaviest smoke right now. At a KP4, I would expect to see it right now, because of the magnetic reversals, close to the borders of Michigan. A KP3, I would say mid-Wisconsin, mid-Michigan, mid into the maybe South Dakota. I would not expect for Indiana, Illinois, Pennsylvania to get auroras. If it merges up into the 6 or 7, then most of the United States may see auroras. If we get a scoop shovel event, then expect spikes in activity that may reach that 6 or 7%, or that KP 6 or 7, and you may end up seeing auroras wherever you're at. So be watching your numbers. I use the app Aurora Alert. I have found it to be the most accurate, and it does use, I believe, local time, so it is not on UTC time. If I remember right. And right at the moment, we're at a KP3 at 466 kilometers per second wind speed, which is not bad. We're at a zero density, or at a zero BZ, which is neither good or bad. That's right down the middle. And we're at a 1 density, which is not great, but it's not horrible. If the density picks up and we go negative after dark, then the northern hemisphere will see it. If we go positive, and there is a positive number, then the northern hemisphere will not see the auroras more than likely, unless it's an outrageous density and an outrageous wind speed. And I'm classifying this because there are variables. Typically, you have to have a negative number, but there are times with a very high wind speed and a very, very high density that even with a positive number, we have seen auroras in the northern hemisphere. But it's rare. Normally, you want to have that negative number. But if the wind speed is like really weak and down under 500 kilometers per second and it's a positive number, then pretty much you're not going to see anything. If you have high humidity, chances are you might not see anything. If you have a full moon, it's going to be harder to see something. Doesn't mean you won't see anything. It just means those auroras won't be as bright. If you have smoke, like humidity, it means you're not going to see the auroras as easily. So this, if the numbers say and everybody's saying it should be there, then you need to look at your other factors like humidity, smoke, sand from Africa, and whether you have the moon. chances are one of those other things or a combination of those things are affecting your viewing. And that, in a nutshell, is your science. I do teach classes. I will be getting back to classes after I get our North American art products off the ground and making money. Those that follow me regularly know that the art products is there. We have clothing, we have gift items, we have Christmas items, we have cell phone covers, we have things for technological geeks that love techie things. We have wine glasses, we have drinkware, kitchenware. I'm still creating product. I'm still out there shooting for products. The goal is we start raising the money. I have a mobility device to get. I'm currently writing grants to get that mobility device so that I can get out in the backcountry safely without risking injury to myself, and handle things like sand and snow and rough terrain without being in danger. We may eventually have to do a fundraiser if all the grants don't pay off. I'm also with the business hoping to raise the money to get a camper van. Some of you know that I am losing my place to live soon, and rather than go to an apartment, we're going to go to a travel van, and I'm going to be traveling to get the various lighthouses around the Great Lakes, down through the East Coast, Florida and Texas in inclement weather up here. And we'll be taking you on those adventures as I create new product. And my daughter will be here, the stationary office person for the art products. But that is the game plan. So please like and share what you can and help me out with that so that we can make sure I have a roof over my head and we're moving forward with the goals, and so that we have more adventures together. Eventually, I do want to take North American products to a nonprofit organization. I am looking for the right people that know how to run nonprofits, that are just excited about dark sky stuff, would like to work on projects that move us forward to my goals with North American Dark Skies. I want to see us creating product line, a magazine, maybe starting some memberships up to where we can start buying property and creating dark side campgrounds, and being able to give grants to areas to help create more dark sky space but I have to find people that know how to run a nonprofit organization and know how to do those things. So if you're somebody that knows how to do that, please contact me. That's next on the agenda for North American Dark Skies, is we want to do that because I can't do everything at once. And I need to make a living now because I have to have a roof over my head, and this needs to go in a place that we're creating more dark sky spaces. So I need some helpers and some people that are really on fire that want to make this something that is for everybody. Going to leave you with that. Happy hunting tonight. Be safe. Get into groups. For newbies, groups are all about meeting people, about finding people that you can hunt with, about hunting safely. And I will make another post about that at another date. All right, everybody have fun.